the flight instruments, also known as the six-pack. So the flight instruments indicate what the aircraft is doing. Basically, its attitude and direction, whether it's climbing or descending, the airspeed of the aircraft itself, and whether you're in a coordinated turn. So let's go through each of these instruments. So these instruments are all located in this area right here. These are what we call steam gauges. They're the old style gauges that you see in a lot of older aircraft, particularly anything older than 10, 15 years old. Newer aircraft have digital displays, but they basically show the same information that these items show here. So let's first start out with our first instrument, which is the airspeed indicator, and that's located right here. What I'm going to do, we're just going to zoom in here real quick. And you'll look at the airspeed indicators. A couple things we want to focus on here with the airspeed indicator itself. We've got a white arc right here. This is showing, there's several pieces of information that it shows here. The one though the reason we have the white arc is to indicate the flap extension speed. So we can extend the flaps or have the flaps extended at any speed below this top of this white arc right here. If the flaps are out in this airspeed up here, we could actually damage the aircraft. So this is it. At the top of the arc, it's showing when we can start extending the flaps. Down at the bottom of that white arc, that's telling us the stall speed with the flaps out. So when the aircraft gets to a real slow speed, at some point the wings are going to be able to produce enough lift to keep it in the air, and the plane is going to start a stall. It's going to basically, the wings are going to stall, and it's going to start descending. So this helps us identify where that location typically is. It's not always right here. It depends on temperature and other conditions there as well. So the other thing here is the green arc. So the green arc is located right here. You can see that right there. That shows the normal operating range of the aircraft, the airspeed. That's the normal operating range of the aircraft. So at the high end, where we hit the yellow area, that's the caution range there. But the green is typically what you're going to use. You're going to be flying in this green range for most of your cruise flight and most of your practicing flights. You're going to actually go out and stay within that airspeed. Now notice again that the airspeed here, which is it's indicating about 48, 47 knots, somewhere around there, it stops right there. That's where the aircraft, again, the wings stall with the flaps retracted. So again, as you remember, the white arc is with the flaps extended. The flaps with the flaps retracted, the aircraft is going to stall at basically at this airspeed here, which is about 47 knots on there. So notice we've got knots we're reading there. And then we have the yellow arc right here. That is our caution range. So that's the turbulent air penetration speed. So essentially, when the airspeed gets up to that high, you're flying really fast, right? So the wings are designed to handle airspeeds up to, in this particular aircraft, up to about 165, 167 knots. Beyond that, you're a test pilot. And the wings could warp, or I mean, if you fly really fast, the lift could be so great on the wings that it actually breaks them off. And I think there's only one case in history where that's ever happened, and it was intentionally done. But it's very rare for a person to damage a Cessna 172 by exceeding that speed. But again, you don't want to become a test pilot, so you want to keep your airspeed under that red radial mark right there. Again, that's the never exceed speed. The yellow arc here is the caution range, and the red radial line there is the never exceed speed. So if you see that on an airspeed indicator, again, you'll know you should never cross that line. The caution is area right here. Again, that's a turbulent air penetration speed. So if you're in really bumpy air, you want to stay out of that airspeed area there and stay closer to the green arc. There are other airspeeds that are not shown on here, primarily your maneuvering speed. You'll get into that more as you take more classes and lessons in flying there. So that's the airspeed indicator. The next one is our attitude indicator. So to understand this one, we need to go back to our full view out here of the cockpit. So the attitude indicator, also known as the artificial horizon, is essentially that. It's an artificial horizon. Out here we've got a real horizon right here. This is artificially showing us the horizon inside the cockpit. That way, if we run into clouds, we can kind of get an idea of whether we're right side up or in a turn, a climb, descent, or whatever. All of these things are going to show right here. So let's actually unpause our sim here. And what I'm going to do here, we're on autopilot here. I'm just going to turn the aircraft to the west here. And notice how the artificial horizon mimics the real horizon out there. And again, that's so that we can read this instrument if we go into clouds, or if it's really hazy, we're having a hard time seeing that horizon, we can use this as our artificial horizon there. You can see how it's showing the horizon there. That's the attitude indicator, or the artificial horizon. The next instrument we're going to talk about is the altimeter. That's right here. So it looks just like a clock. The only difference here is instead of going from 1 to 12, this goes from 1 to 10. So we've got 1, 2, 3, 4, 5, all the way up to 10 right here, or 0. It would be 10 there. So the small needle here indicates thousands of feet. So if I just read the small indicator right here, it's reading roughly 1,000, about 1,500 right there. You can see where it's pointing roughly at about 1,500 right there. The long needle right here is, you read that in hundreds. So we'd say 1,000 right here, and then we go to the long needle and 500. So 1,500 feet is what we're at right now. The other, this needle right here, this one actually shows tens of thousands. So if this little marker right here was up, pointing right here, that would mean we're at 10,000. Or if it was pointed up somewhere in this area right here, we'd be indicating, in this case, it would be 11,500 feet is what we'd be reading there. If this was the small needle right here was right there, and the long needle right here is right there. Again, that's going to be the 10,000s of feet right there. The other part of this is your altimeter setting. So we use this right here. If you look at this right here, I can adjust our altimeter setting, and you'll get into this more in your lessons. This adjusts for non-standard pressure in the atmosphere, and it happens, all the time when we're sitting on the ground. We don't know it, but the pressure is constantly changing. So this compensates for that, so that our altimeter can read accurately on there. All right, so let's go down here to our turn coordinator. The turn coordinator doesn't show bank or pitch information. It shows your rate of turn. So notice it says 2-minute here. What that means is if we actually go into a turn, let's actually do this here. Let's try to, well, yeah, we'll go into a turn here. So watch this. I'm going to turn the aircraft and see how it shows the aircraft. It looks like it's banking, but it's going into what's called a standard rate turn. The wings are lined up with this little line right here. So it's going to take us 2 minutes to do a full 360-degree turn at this rate. Now we're starting to level off there. So that's what that instrument shows. Is it our rate of turn, not bank? It doesn't show pitch information. It just shows us the rate of turn. And then there's this little tube right here, and it's filled with a liquid, and then you have a little metal ball in there. That works just like a level. And what it's doing is it's showing us the center of gravity. So right now the center of gravity is pointing down. So let's do this here. So if I right now our center of gravity is pointing straight down like that. If we turn the aircraft, let's see what happens here. We might see how the ball moves a little bit. That means we'll pause it here a second. Our gravity is shifted very slightly. We might be able to feel it in our seats, but the gravity is shifted a little bit to this side over here. So again, let's do this. So our gravity is now kind of pointing in that direction just a little bit. So it's tugging on the ball to get it to pull it in this direction. What we want to do as pilots is we want to cancel that out, and we cancel it out by using the rudder pedals. That's how we cancel that the ball swinging back and forth. Um, we want to keep the ball centered at all times. It'll make it more comfortable for the passengers, but it's just good piloting when you can go ahead and use your rudder pedals when you go into turns. That ball's going to be swinging a lot back and forth, and if we use our rudder pedals, we can kind of nullify that so that it's always in the center there. But it does take practice. Okay. All right, and the next instrument we have here is our directional gyro, our directional gyroscope. This is a gyroscope. It doesn't work like a compass. So if I go up here, this is our compass. It's driven off of the Earth's magnetic field. The gyroscope, however, the directional gyro is based on a gyroscopic tendencies called rigidity in space. We're not going to get into that right now. That's a little bit later on. We'll discuss that. But essentially, what this does is it shows us our direction. So we've got north right there, west. We're just a little pointing a little to the south of west when we go out here. So we look at our directional gyro. West is probably over in this direction over here. So if we, oops, yeah, if it's kind of over that way right there. And here we're just showing that we're a little south, or we would actually read it at 240 degrees on the directional gyro right there. So we start out with north, which is actually 360 degrees. That's north, and then 30 degrees here, 60 degrees, 090 or 90 degrees, 120, and so on and so forth. 180 for south, and west is 270 degrees, and then all the way back up to 360 degrees. So that's how we tell our direction in the aircraft with a directional gyro. Okay, and then lastly, our last flight instrument in the six pack is our vertical speed indicator. So this is going to actually show whether we're in a climb or a descent. There's a slight delay in it, but for the most part, it's going to indicate whether the aircraft is currently climbing or descending. So let's unpause it here and watch what happens with this. What I'm going to do, I'm just going to change our altimeter a little bit to get the autopilot to trick us into going to a higher altitude here. So. Oh, do we have that? Okay. Well, we'll pull back on the control yoke. So watch our vertical speed indicator. Can you see how it's going into a climb there? I'm holding my control yoke back. It's showing a climb now. Whoops, we got to get our nose back there. So let's go ahead and give her full throttle there. Oops. All right, there you can see that vertical speed indicator really going high now. So now it's going into a descent. So you can see it's fairly quick, but there's a slight delay there. When I pull the nose up, it doesn't respond right away. It's just a small delay, but it's showing our rate of climb or rate of descent. So if I can stabilize this right here, so let's push that in a little bit right there. So now we're pegged at, let's move that over there. Let's get our autopilot turned on here, and let's turn on our altitude hold on the autopilot, and now we can kind of see what's happening here. The autopilot's trying to get us back up to our altitude here, and now as it does get us to our altitude, it's going to drop and stabilize, and it's going to show a 0 climb or descent there. And again, that's our rate of turn. If we look at it again, we can look at, there's a lot of information on here. We've got the green up and red down. Also, it's showing in hundreds of feet per minute. So this reads as 500 feet per minute right here. This reads as 1,000 feet per minute. That's 1,500 and then 2,000 feet per minute. So if the dial goes up this way, it's 2,000 foot climb. And down this way, it's going to be a 2,000 foot descent. We can obviously look outside the aircraft and see whether the aircraft is climbing, but that's for a little bit more precision flying. So a good instrument to use. Again, that's your six pack. Again, they're also called the flight instruments. And we can also see the same in digital representation as well. There are concepts called tapes in a digital instrument instead of the dials. But basically, they have the same information that's presented here.